let's have a look at relative frequency and theoretical probability. Now, this is all revision, so none of this should feel new to you, and hopefully it will feel familiar. So relative frequency is also known as experimental probability, and it's when you determine the probability of an event that happens from an experiment or a survey. So we need to consider the frequency of the event relative to the total frequency. Okay, here's an example from our textbook, the table showing the scores that a class earned on a maths test. So the scores go from 4 to 9 and we can see our frequencies there. Part A asks us to find the relative frequency for each score in the table in fraction form. Okay, so let's have a look. First thing we need to do is consider the frequency of the event over the total frequency, which we have to find. Adding up all the numbers, the total frequency is 23. So let's make our fractions down the side, and we're just comparing the frequency with the total frequency. Okay, you can fill that in. Now you can be asked to give your answers as fractions or as decimals, so just read the question really carefully. And apologies for my dodgy little fractions there, but I didn't leave myself much room. Now part B says, if a student is chosen at random from this class, find the probability that this student scored 8. Okay, how many students scored 8? There were 2 of them. So the probability is simply 2 out of 23. Next, what is the probability that the student scored less than 7? So probability less than 7. I only need to consider 4, 5, and 6. So be careful with that. Adding up those 3 frequencies will give you 11. And that's 11 out of 23. Now the next question asks for the probability that the student passed, given that the pass mark is 5. So in this case, we need 5 or more. 5 is the first mark that is considered a pass. Read the question carefully and you can use the notation that matches, because in this case, it's greater than or equal to 5. Okay, well that means 5, 6, 7, 8, 9. So you can go through and add up all of those frequencies, or you can shortcut and say, well, in that case, the probability is everything except the 4. So I can use complementary events and say it will be 1 minus the probability of getting a 4, because that's the only way you can fail. And that is 6 out of 23, which gives us a probability of 17 out of 23, which would be the same thing you get if you add up all of the other scores. And then part C says what score is most likely and least likely. Okay, so consider the probabilities. The most likely score is the score with the highest frequency or the greatest probability, and of course that one would be 7, which also has a frequency of 7. And the least likely score, of course, would be a score of 6. Very good. And now let's have a look at theoretical probability and some important definitions. Now, mutually exclusive events are events that cannot happen at the same time. So if we are considering the probability of event A or B happening, then you simply add their probabilities. And that's called the addition rule for mutually exclusive events, where the probability of A union B, the word union meaning A or B, or both, but in this case there can't be a both, okay? But the probability of A union B will be the probability of A plus the probability of B. Now we know that probability lies on a scale between 0 and 1. The probability of an event is between 0, impossible, all the way through to 1, which is certain. And we know the sum of all probabilities is 1. That gives us complementary events, where the probability of something not happening is 1 minus the probability of that event happening. So the probability of the event happening plus the probability of the event not happening can be 1. And the notation we use for complementary events can look like this: E with a bar over the top, or E with a dash, meaning not E, or even a new one, E with a little C at the top, meaning the complementary event. All of these mean the event not happening. And now some examples from our textbook exercise 703. Question 1. Alana is in a class of 30 students. If one student is chosen at random to make a speech, find the probability that the student chosen, A will be Alana and B will not be Alana. Okay? Now, Alana is one person, so the probability she will be chosen is 1 out of 30. Of course, the probability that she won't be chosen is 1 minus the probability she will be chosen. So P, not E, is 29 out of 30. Now, question 8 says the probability of a bus arriving on time is estimated at 18 out of 33. So the probability that our event happens, bus on time, is 18 out of 33. A, what is the probability that the bus will not arrive on time? Okay, well, if probability E is 18 on 33, then of course the probability of not E is 1 minus 18 on 33. and that gives us a simplified answer of 5 on 11. Part B says, if there are 352 buses each day, how many would you expect to run on time? So this is the expected frequency based on our theoretical probability. Well, we can expect 18 out of 33 of the buses to be on time. So 18 out of 33 of the 352 buses will give us 192 buses. And hopefully that's helped you remember how to solve some of these probability questions.